Okay, we're back now. This is the lesson for Monday, January 7th. All right, so what we want to make sure we can do here are I can statements. And this is taken from the handout today, which is actually page 3 of the pink packet. Unfortunately, within the packet, there's not a lot of room for notes, so we're just going to put this in with it so that we have some notes to use. Okay, I can statements. We want to make sure that you can say that I can graph quadratic equations by finding the vertex and using a table of values. And you want to be able to determine the domain and range of a quadratic function. Okay, those are our goals for this lesson. Our new vocabulary: double root, domain, and range. Okay, so the double root would look like this. If you're looking at this, let me zoom in on it. You'll notice this, highlight it a little bit, I'm not sure. Oh, I marked on this. This one, it's not marked on. So you can see right here, oh, there's a 0 there. It makes it kind of like it might be touching in more than one spot. But the point of the double root is that what happens is the parabola comes down, it touches in one little spot on the x-axis, and it comes back up. So that double root would be when it just touches once, as opposed to two unique solutions where a graph will start, a negative graph will start increasing, hit a certain point, and then come back down again. Now notice it crosses the x-axis at two different places. So that's two unique real solutions. This is one unique real solution and a double root. So if you didn't write that down, write it down now so that those are interchangeable. And then the other kind of solution we have is no real solution, which means that our graph comes down but it never touches the x-axis. It could also be going this way. So it could also be coming up and our x-axis is along here, but it doesn't quite touch. So it can be going in a positive direction or a negative. Either way, the key is it does not ever touch the x-axis. So there are no real roots. Roots would be those numbers where the graph actually touches or crosses the x-axis. So that explains the roots. And then domain and range. What are the x values that work with any function? So that would be what are the values along the x-axis that we can use for the function. And then for the range, what are the y values in the function? Range is the important part when you're looking at parabolas, because range is going up and down. So it's the vertical numbers. So looking at this equation, this function, it starts down, it goes up to a certain point. So our range is going to say that, say for instance, if this point here was at a 2. So if that is at y equals 2, then our range, our y values would be everything less than 2, because this is going downward from there. So this is a max. So the highest it gets, y equals 2. On this would be a minimum. And our range on that would be y. All the y values are greater than 0. So we looked at our vertex above, in the problems above this. And we had to figure out this one, number 3, the vertex of a rocket. So a rocket goes up, and it goes so far, and then it starts coming back down. So the range on that, the vertex on this one, was at 2. So x here was at 2. And y is at 65. So this vertex was at x is 2, y is 65. So my range would be y is less than 65. Okay, that's what we mean by range. And it is always the y value of the vertex. A range will always be the y value of the vertex. Okay, now what we're going to be doing is graphing by using a table of values. All right, so the first thing we're doing, this is example 1. First thing we have to do is we're going to graph by making the table. So first thing, find the axis of symmetry. It's very important that we use the right x values when we create a table of values, because what we want to make sure we're doing is seeing what is happening around the center of the equation. So we have to know where's the vertex. So first thing we do, we don't just guess and say, okay, I'm just going to use a -1, 0, 1, and 2. No, we figure out what the vertex is. So looking at the equation, y equals x squared plus 10x plus 26. Find the axis of symmetry by using the formula x equals -b over 2a. So on this one, a is coefficient in front of x squared, which is a 1. b, coefficient in front of the 10 to the first, x to the first, which is a 10, and then c, the number sitting there by itself without a variable, 26. Okay, so then I'm going to figure out what my axis of symmetry is. Let's back this up. So my axis of symmetry, x equals b is 10, so -10 divided by 2 times a, which is 1, which comes to -10 divided by 2, which comes to -5. Okay, that's one part of the equation I need. So now I substitute x equals -5 for x in the equation, x squared plus 10x plus 26, and find the y value. So y, if x equals -5, y equals -5x squared plus 10 times -5 plus 26. So y equals -5 squared, that's -5 times -5, 25, positive, minus -5 times 10, 50, plus 26. And when I add all those numbers together, y equals 1. So my vertex is -5 and 1. So now, knowing that, I've got this written out. When we make a table of values, we'll use 5 x values, which, what I mean by that is 5 spaces, okay? So 5 values, x values. What we want to look at is, notice, right here, the -5 went in the middle. So we take our -5 and we put it in the middle of our table. So think of this as not having those two numbers yet. Let's just do that. Let's just white this out so you understand what we're talking about here. Okay, so I just figured out what my vertex was. Now I write my table, and all I need is 5 points. 1, 2, 3, 4, 5. I'm going to put that -5 in the middle. And it's important that you put it there, because that way you'll put the right numbers below and the right numbers above it. And that is a 1. Okay, so the number just below -5, -4, then -3. then negative 6, then negative 7. Okay, that's the table of values because I need to go around the center of my equation. I don't want it to be, if I don't have the right spot, for instance, if I did this and I just went 0, 1, 2, negative 1, 0, and 1, 2, my equation would look like that. I would only have part of it. I wouldn't have a clear picture of what that graph is doing. So, very important always. Figure out your vertex, put that number in the middle of the table, and then go down from there to up from there. Okay, so then what I have to start doing is plug in the rest of the values. So I do negative 3 squared plus 10 times negative 3 plus 26. So that is going to be 9 minus 30 plus 26. And negative 30 plus 26 is negative 4 plus 9 gives me 5. So negative 3, 5. Now I'm going to do the same thing for negative 4, negative 6, and negative 7. So just to make sure you understand how to do this, because I'm finding that a lot of you are confused when you have to do these equations. So I'm going to rewrite the equation here. Y equals x squared plus 10x plus 26. And then y equals negative 4 squared plus 10 times negative 4 plus 26. And then I'm going to keep going through. And then I'm going to do the same thing with negative 6, negative 7. Now when I've done that, I'm going to end up getting a 2 here. I'm going to end up getting a 2 here, and I'm going to get a 5 here. Now, don't just write in those numbers. Work it through and make sure you get the same thing, because you have to know how to work those through. Okay, the key here is notice this number matches that number. Those two are the same. Now notice these two are the same. That's what we're talking about with our symmetry. Those values will end up being the same because here's our center, and we're going the same amount up here that we go here. So those points should be exactly the same y values. So here's our negative 6 is here, and our negative 4 is here, and those 2 points meet. And then, and hopefully that was at about 2. And then the next thing we're going to is 5, and that will be negative 3. Goes up to 5. There's a point. And negative 7 here. And it's also at 5. So here's our symmetry. That's the way that symmetry works. So this point, negative 3, 5. And this one is negative 4, 2. And then it matches over here. Negative 7, 5. That is a 7. Sorry, that's kind of sloppy. And then negative 6, 2. So notice how same y values. Here, same y values. And that's how we create the symmetry for those. Now, questions that you want to be able to answer. We plot each of those points, compare our answers with our neighbors, and what do we notice about the points? The symmetry. They're bookends. The top number is the same on the y value side. The top number is the same as the bottom number. And then the next one up to the next one down. And then the middle number is all by itself. Okay, that's the way it should end up being. Good luck doing the rest of them.